Continuing the 5 methods to solve for this JEE advanced question. So 2 methods we have already seen. Now we are seeing the third method. So in 2 methods, what I said, linear SHM you can use, that the center is getting displaced. So F is equal to minus of kx. Then about the bottommost point, it is performing pure rotation. All the purely rolling objects perform pure rotation about the bottommost point. So about bottommost point, you can consider it to be angular SHM. Write the torque about bottommost point, then equate it to I omega square theta using the moment of inertia at bottommost point. Now next one is considering angular SHM about the center of the disk, which is center of mass. So basically center of mass of frame only is the point about which you will be able to write angular SHM again. See, for purely rolling objects, we have this point about which it appears to be performing pure rotation. So if it is performing oscillation, you will be able to say that it rotates this side, rotates this side. So it is angular SHM. Another point is the center of mass, because when you are sitting at the center of mass frame, even if it is performing CTR, combined translation and rotation, even if it is performing CTR, what you will say that this speed I cannot observe, right? Because you are sitting at the center of mass frame, so this velocity becomes 0 with respect to center of mass frame. So it means it can only perform omega. So if it is not performing proper rotation, then it is performing rotation like this side and then this side and then this side, to and fro rotation about the center of mass. It means angular SHM. So now we'll be writing the torque about the center of mass and then solve it again. So for this, if you observe what all forces will be acting on it, so when it is displaced a little, here we have mg sine theta, kx, normal will be from here, mg will be there, friction will be there, right? And kx I already said. And because you're sitting in the accelerated frame, basically the center of mass, once it is shifted, it was present here, once it is shifted from here to here, it is having forces acting on it. So it means it is accelerated, center of mass is accelerated here. But the acceleration which will cause some pseudo force, that pseudo force also passes from the center of mass only. So all the forces which will be passing from center of mass, their torque will be 0, like mg, pseudo force, normal, kx, spring force. So only friction will have some torque. What will be torque of friction? So friction is acting at the bottommost point, at the contact of disc and the ring. So this friction is acting at how much distance from the point about which you are trying to write the torque? It is r. So F into r. F into r. Now from where we find the F? So in previous cases also I have told you how to find F. If not, again see it. So what do? We know that center of mass is accelerated. So what are the forces on center of mass? mg sine theta plus kx minus friction equals to m into a of center of mass. Now we also write the torque. So first mg sine theta plus kx, friction previously by writing the torque of friction equals to I alpha, then equating because it is performing pure rolling. So by performing pure rolling, alpha and a of center of mass we have equated, and friction already I had written in previous cases that it is ma into center of mass by 2. That I'll keep here. So here then it goes on the other side, it becomes 3 by 2 into ma. A is a of center of mass. So from there we will get friction is equal to ma by 2, that is mg sine theta plus kx divided by 3, because ma by 2 is required. So this is the friction. Now write the friction's torque. So this is the friction, this is friction's torque when you multiply r, equals to, now because we are writing the torque about the center of mass, you have to write moment of inertia also about the center of mass. So this is mr square by 2, disk mr square by 2, omega naught square theta dash. Now theta dash is the angular displacement, right? Angular displacement, we know angular variables seen from anywhere, they are same for a rigid body. So theta dash. So now this theta dash we will have to either replace in terms of x, or x we should replace in terms of theta. Same, this theta, all of them should be replaced in terms of any one variable. So we already know this relation, so any one of them you can use. So here I have used theta dash. So theta I will be replacing in terms of theta dash, x I will be replacing in terms of theta dash, and here already we have theta dash. Again equate it, solve it, you will be getting the same answer. Next is energy method. Just go through the third method first, understand it properly, then we will see the fourth method, energy method.